Welcome, Heron and Riverside Scholars. If you are in Claywell, Sutton, or Parsons Algebra 2 class, you have come to the right place. For some of you, this is a new voice. This is Miss Parsons over at Riverside. And today we're going over Skill 20, Simplifying Radical Notes. So some things you need to know about radicals is that if we have two things under the radical with an index of n, we can split them up, keeping the same index. If they are divided under a radical, we can split those up with the same index. And we can also rewrite them as a fractional exponent where we take the power over the root, so m over n. Okay, some of my students remember at the beginning of the year, I drew this beautiful picture with some tree lines, or power lines, tree lines over it, to remember that it's power, because the power lines are over the root of the tree. So maybe that's just a little way that can help you remember. So to simplify radicals, we're going to identify the root or the index, break it into primes, okay, maybe using a factor tree if you need to, and group them. Each group form moves to the outside radical, and if it doesn't have a group, then it has to stay in the radical. And step 4 is to rationalize the denominator. So if I look at example A, I want to identify what the index is. Okay, so that is that number that's right here. Okay, we don't see one, so it's an invisible 2. This is a square root. Okay, so I'm going to break these up into their prime components. So the primes of 4 are 2 times 2. And then I'm going to write out my x's. 1, 2, 3, 4, 5, 6, because there are 6 of them underneath this radical, x to the 6th power. So I'm taking out groups of 2, getting that from my index here that's highlighted. So I have here a group of 2, a group of 2, a group of 2, and a group of 2. If it is grouped, it can come out of the radical. So I'm bringing out a group of 2, bringing out a group of x's, another group of x's, and another group of x's. Okay, brought out the 2's, group of x's, a group of x's, and a group of x's. So since they are paired, they can come out of the radical, which makes this 2x to the 3rd power. There was nothing left inside the radical, so it just disappears. Okay, on B, my index is 3, which means I'm going to be taking out groups of 3. So if I was going to rewrite B, that means I have 3 A's and 6 B's. 2, 3, 4, 5, 6. Okay, so let's take out or circle our groups of 3. So there's 3 in that one, 3 in that one, and 3 in that one. Okay, so if it's in a group, it can come out of the radical. So I have a group of A, write my 3 up there. I have a group of B's and a group of B's that are coming outside the radical. Okay, anything left in the radical? No, there's not. Okay, so it can just go away. Simplify this. I get A times B squared. Okay, for C, what is my index? What am I going to be taking out groups of? I'm going to take out groups of 4. Okay, it can be very, very tedious to continue writing these variables out. Okay, so I'm going to do it a different way where I'm writing them as groups of 4. So x to the 4th is already its own group of 4. Y to the 8th can become y to the fourth times y to the fourth, because 4 plus 4 is 8. And z to the second, I can't make a group of 4, so it just stays where it is. So let's circle our groups of 4. This is a group of 4, this is a group of 4, and this is a group of 4. So what's coming out of that radical? An x, a y, and a y. Because once I group them, they could come out of the radical. What did not make a group of 4 and has to stay in the radical? Z squared. So this becomes x times y squared times the fourth root of z squared. I am notorious for forgetting to put my index. Okay, remember to put your index on there so we know that it's a fourth root. All right, let's move to D. Okay, here I'm going to make groups of 3. Okay, let's do negative 27. Okay, that is negative 3 times negative 3 times negative 3. C to the 6th, I'm going to write that as groups of 3. C to the 3rd, C to the 3rd, because C to the 3rd times C to the 3rd is C to the 6th times B. Let's circle our groups of 3. That's a group of 3. That's a group of 3. And that's a group of 3. So what's able to come out of the radical? Negative 3. C. C. There I go again. Okay, and what has to stay in the radical because it didn't have a group to come out? B. So this becomes negative 3 times c squared times the cubed root of b. Okay, for E, what's our index? It's not there, but we know it's a 2. Okay, we can use our little trick from earlier, the root of a quotient, to know that I can write this as the square root of 75x over 50 and write it into one big radical. Okay, and then I can reduce these 75 and 50 to become 3x over 2. Okay, almost done. But if I split this back again, okay, putting in their own separate radicals, I have a problem down here because I am not allowed to have a radical in the denominator. So I have to do what we call rationalizing the denominator. All right, Miss Parsons, let's just make a mess. So I have to rationalize it by multiplying by the square root of 2 over the square root of 2. 3x times 2 becomes 6x over square root of 2 times square root of 2 is just 2. Okay, last one, F. Okay, great news to make this a lot easier. 64 and 256 are perfect fourth roots. So we don't have to combine the numerator and the denominator like we did on example E. Okay, here I can split this up. Okay, pray that I have enough room to write this. My first one, the fourth root of 64 written as a group of 4 is 2 to the 4th power. 2 times 2 times 2 times 2 is 64. Okay. This one down here, breaking them up into groups of 4. 256 is 4 to the 4th power. M to the 5th, I can break into one group of 4 with 1 left over. N to the 10th, I can break up to n to the 4th. N to the 4th gives me 8 with 2 left over. Okay, so what all is going to come out of the radical? A 2 is. Okay. A 4 is going to come out of the denominator. An M gets to come out. An N gets to come out. Another N gets to come out. So that makes that N squared. And what has to stay in this 4th root? I had an M here that has to stay. And I have an N squared that needs to stay. Okay, so now we have to rationalize the denominator because we cannot have this in the denominator. So we're going to multiply everything by the 4th root of mn squared over the 4th root of mn squared. So in the numerator, that's going to give you 2 times the 4th root of mn squared. Okay, now this bottom one can be a little tricky, but all you really have to worry about are knowing that those are the same. And when those are the same, we still have the 4mn squared here. Okay, but what happens when I multiply these two together? I get whatever's inside the radical, mn squared. So I'm going to combine my denominator now. Get 2 times the 4th root of mn squared over 4 m and m, make m squared, n squared and n squared, make n to the 4th. One last step that we can do. I've got a 2 in my numerator and a 4 in my denominator, and those can reduce to 1 mn squared over 2 m squared n to the 4th. All right, I know that was a lot thrown at you guys. Remember, you can pause this video, go back and watch it, shoot us emails, step into office hours. Hope you guys are doing well. We miss you very much. Have a good day, you guys.